topic is optical instruments. The instruments which has optical characteristics. There are two types of instruments we will study. One made by the nature and the other which are made by the mankind. Okay? नेचर ने जो ऑप्टिकल इंस्ट्रूमेंट बनाए हैं उसमें सबसे अच्छा, सबसे अजीब ऑप्टिकल इंस्ट्रूमेंट है ह्यूमन आई. सो वी विल स्टडी अबाउट ह्यूमन आई, हाउ इट डील्स विद द लाइट. लाइट से किस तरह से ये बिहेव करते हैं और किस तरह से हमको दिखता है. ओके, सो ह्यूमन आई. Human eye, how it is made. So we will have a certain method of studying. First, we will have description of the human eye. Then, which are the main characteristics or how it works. Working of each part. See, how do we see the objects? Then, what are the defects possible? Seeing, that is image formation. Then, what are the defects possible? There are many types of defects, biological and optical. We will restrict ourselves to optical defects and their rectification. Okay, optical defects, their rectification, and we have to do certain calculations for these rectifications. How the rectifications are calculated. So this will be our flow of study, how we will study it. So first we will come for description. Ball, eyeball, what we see from outside has got a ball shape, and this ball has 2.5 centimeter size. The size is 2.5 centimeter diameter. Okay. This ball is made of a hard shell. That hard shell is known as sclerotic. Now this sclerotic, what does it do? It just contains all the parts inside it. So this is the first part, sclerotic. This is a white material, a hard material which contains all the parts of the eyes. Okay, inside sclerotic there is choroid. Choroid is a black layer here, and this black layer, the color black, optically helps for non-reflection of the light. If the light does not reflect inside, the image will be sharp and focused at one place. There will be no reflections. So that is the purpose of black choroid. Plus the choroid holds many points here which are sensory points. Those sensory points can sense the light. When the light comes from those sensory points, these are converted to electrical signals which are sent to the brain. Okay, we will come to that. First, let's see here. This portion of the ball, this portion is totally transparent, the front portion, and we call it cornea. This skin which is transparent, the front portion, this is cornea, that is just below our eyelids. It allows light to enter. Cornea, transparent, transparent material. What does it do? Allows light to enter and protects. Whatever are the features inside, it protects it. protects inside. So this is our covering of the eye. Just below the eyelid there is a cornea. This cornea is transparent, totally transparent and very clean. Okay. After cornea there is another window. You can say that window is iris. Again, iris allows the light energy to enter. The formation of iris is like a hole in this way. The hole which can be increased in size, which can be decreased in size according to our will, according to the signal received by the brain. Why it is required? It is required because the energy of light which is passing through the eye and which is used for making images, that energy should have the right quantity. It should neither be a glare, means excess of light, nor it should be short, nor it should be less energy, so that image is not formed clearly. Like we get the images in the dark room, we can't see the things. So we need more light. We need a particular quantity of light to make a clear image, and that quantity of light, if it is less, then brain asks iris to increase the size of window. If the light is more, there is a glare in the sun, then the brain asks iris to decrease the window, and this window is iris. This opening, the window, the opening, we call it pupil. So pupil is not a part. What is pupil? Pupil is nothing. It is only a passage from where the light can pass through. That is pupil, and all around it, this shutter, which is opaque, that is known as iris. This iris, when we see from outside, it has a particular color, and this is known as color of the eye. The brown color eye, the blue color eye, that color is basically color of the iris. Okay, so what is the purpose of iris? To control the quantity of required light. To control quantity of light required for appropriate image. Appropriate image. How should be image? Image should not be dark. It should not have glare. No dark, no glare. And that control is done by the iris. And this is something for which in class 10 you have studied what happens when we go inside a cinema hall, in a movie hall, and we are not able to see the things for a few minutes. We all know the answer of this, that when we go from outside, the outside amount of light is high. According to the instruction of the brain, the size of the iris is already very small, because the small opening of pupil is sufficient to send the sufficient light. But when we go inside the hall, that small opening is not sufficient. If the small opening is not sufficient, the light going is less to make a bright image. So we are not able to see the things because the light going is less. This sense is sent to the brain, the signal is sent to the brain, and the brain again gives a signal to the iris to increase the size, and that increases the size. Then sufficient light enters, the image is formed, but this takes some time. This takes some time for the iris to stretch. It may be a minute or so. That is why after 1 minute we are able to see the things clearly, even inside the dark cinema hall. The same thing happens when we come out in the sun. If it is wide enough, the lot of light is going inside, which gives a glare in the retina, and we are not able to see the things. Again, the signal comes from brain to decrease it. So to decrease the opening, it takes a few seconds, a minute, then within that time again it reduces and we get habituated to the bright light outside. Okay, so this is the purpose of iris and it's very important. If we see the side view is here, iris. And this is the opening, and what we call the opening, this is known as pupil. So here, this opening is pupil and you will always see that this is black. If pupil is nothing, then how it is black? Yes, the answer is pupil is nothing, it's only an opening, and what we see inside, is choroid, and the color of choroid is black. So when we see inside the eyes, what we see? All black. So this opening appears to be black, that is pupil. Okay? The lens we fit on the eyes, the lens are fitted on the iris, and that is how the color is changed. It is a cosmetic change. Okay. Now, after this opening, pupil, iris, light control, then the most important part is the lens. Here is a lens. This lens is not a double convex lens. It is same in nature, but it is a double convex lens, but these two radius of curvatures are not equal. It's not a regular shape. The lens is nearly like this. It has got a large radius, less curvature. This side has got more curvature. So this is the shape of the lens if it is observed from the side. Okay, if you observe it from the front, then this is the lens. This lens is made of transparent proteinous matter. This is made of proteins and this is flexible. Flexible means it can be pressed, it can be stretched. This is a wonderful thing and we have not been able to copy it so far. Okay. So this is the lens observed from the sides. This lens is one with the ciliary muscles. This is embedded in the ciliary muscles all on the sides. In the muscle, here is the lens, held by the muscles. Now what these muscles can do? These muscles can press and they can relax it. So this pressing and relaxing. So here I have tried to show it. The lens seen from the side. The ciliary muscles are pressing it or not pressing it. If the ciliary muscles are not pressing it, then the lens is thin. If the ciliary muscles press it, then it becomes thick at the center. When a lens becomes thick at the center, this curvature becomes more, and what happens to its power? The power increases. So, the power increases with ciliary muscles when they press. So, the focal length of the lens can be changed. What will happen with the change of focal length? The position of image will change because position of image in a lens depends upon focal length. This is our formula. So this is position of image. This depends upon focal length and object. Okay, so that can be adjusted by the lens as instruction given by the brain. Why should it change? The answer is it should change so that a clear and sharp image is formed on this surface, and this surface is retina. Okay, so after this lens there is a chamber. In this chamber we call it anterior chamber, and in this there is a liquid filled up that is known as aqueous humor. Okay, after that there is many sensory dots, and this sensing layers, this is known as retina. In retina there are many sensors, and this is most important thing of the eye. When the light falls on retina, all these sensors convert the light into electrical voltage variations. Electrical voltage variations. We will call it electrical signals. Each sensor of the retina, and there are millions of sensors. All these sensors, when the light falls on them, they experience a change. Their light energy is converted into electrical energy, and that electrical energy is an EMF, and that EMF changes according to the change of light. Okay, now that EMF, that change is sent via optical nerves to the brain. When this signals, the voltage signals are sent via optical nerves to the brain, inside the brain the signals are received and a copy of that image is formed. Like in our computer, CPU sends the signal of the image, and on our monitor the image is formed. Similarly, it is sending the electrical signals. Once image is formed here, then the sharp image which is formed here is converted into electrical signals. The electrical signals are sent to brain, and somewhere in the brain that image is again formed, and then we sense something in our brain. That sensing of the image, that sensing we call as seeing. This is seeing. Okay, so we say the image is formed in the brain, and we see, we sense that image which is formed in the brain. So from where do we see? Do we see from the brain or do we see from the eye? The answer is basically we see from the brain. Then what does eye do? Eye help to see that, because the image is primarily made in the eyes, and then the signal goes to the brain, and then we are having a sensation. That sensation is called seeing. If this optical nerve is cut here, then we will not be able to see anything. Even if image is formed here, we will not be able to have that sense. We will not be able to see. That means for seeing, brain is required. इसी तरह से हम लोग सपने देखते हैं. सपने में हमको चीज एकदम साफ दिखती है, जबकि हमारी आंख बंद होती है. हो सकता है उस समय ब्रेन का वो हिस्सा काम कर रहा है जिसमें ये सेंसेशन होता है. उस सेंसेशन को हम देखना बोलते हैं. वो सेंसेशन उसमें हो सकता है, उसके कारण हमको लगता है कि हम देख रहे हैं, जबकि आईज हमारी क्लोज्ड. ओके, anyway, this is the relation between eyes and the brain. But what we are studying, that eye is an optical instrument. How does it work? Now, so this is retina. In the retina, there are two types of sensors. Some sensors are known as rods, and some sensors are known as cone. Rods and cones. There is a difference of their characteristic. The rods cannot differentiate between the colors. Rods cannot differentiate between the color, the red, blue, everything is same for it. It sees everything in grey, but they are very sensitive. So rods are sensitive to light, but no color. No color. Okay? That means in the evening, in the night, when you see the things in a room, how do you see them? We are not able to see their colors, but we see that things are there. Then our rods are working, because the rods can sense, they are very sensitive, a small amount of light. They are able to sense, make the signal, and we are able to see the things, but they don't see color. That is why in the night, in the grey time, we see everything as grey, and we don't see the color. The rods are working. Now, what's happening with the cones? The cone needs a lot of energy, more energy. And here, when we see the waves are going this way, this. So, whether the wavelength is small or wavelength is large does not matter. What matters is the concentration of waves which are falling here. Here 1, 2, 3, 4, 5. 5 waves are gone or 2 waves are gone. Then it will show the image. But what happens here? In the cone, this is one wave going like this. This. And this is the other different color. This. Now this wavelength and this wavelength, these are sensed by the cone because of its shape. This is a corner shape, and this wavelength from this to this distance and from this to this distance. Cone can see this, but rod cannot see that. In the rod, everything will enter. So rod will see only quantity. And even if there are two, the total strength is good enough to make the image, to make the sensation. But here, it also needs two. But if there are two, then this is a different color, this is a different color. It can differentiate between the color, but it also requires 2 of everyone or 10 of each color. That means it needs a lot of light. It needs 10 red, 10 blue, 10 green. Then the cone will act and make a sensation of the light, make the sensation of the image. It needs altogether 10 to make one image. It's very sensitive. It is less sensitive, but this can differentiate between the color. So the cones are responsible for color. But it needs more energy. So in the daytime, when there is sufficient energy, the cones are active and we are able to differentiate between red, blue, green and yellow due to the cones. But in the night time, the light becomes so less, each color has become less, the cones cannot work. At that time, even if the quantity is very small, the rods keeps on working. So, if somebody has got defective rods, what will be problem? If he has defective rods, then in the night time, he will not be able to see the images. That is night blindness. If somebody has got defective cones, then he will be able to see the things, but he will not be able to differentiate between the color, and we call it color blindness. So color blindness is due to defects in the cones, and night blindness is due to defects in the rods, if the rods are not working. So these are the sensory glands or the sensors of retina, and these are all here. Okay. Now, all the sensors do not convert light as efficiently as each one. That means there are different sensors for converting the light, and there are few sensors which convert to a strong signals. Like there is one point, we call it yellow spot. This is a very sensitive spot, and image is formed here that is converted to the best of signals. If it is like that, then what we would like that all the images should be formed at the yellow spot. If images are to be formed at the yellow spot and the light has to go through pupil, then we will make one line here. That means our object should be somewhere here. And the nature has made it very thoughtfully, because when we walk, we have to see the road and see the angle is like this. So without any strain, we are able to see this. Okay, so that is a yellow spot on the retina. Another point on the retina is blind spot. This blind spot from where the optical nerves are going inside, here there are no sensors. If there is no sensor there, so any light coming to that point, we will not be able to see that object from where the light is coming. And there are methods with which we can find our own blind spot. If you keep the eyes straight and put any book near to you, if you bring your fingers, if you bring pencils near to you, you will find you are seeing straight, bringing the things here. There will be one spot where you will find that you are not able to see the object. And at that time, the rays are going to the blind spot. Okay, anyone can find his blind spot. It is somewhere here. Okay, so that is there. Optical nerves carry the electrical signal given by the retina to the brain. So this is almost, we have covered each and every part. Ciliary muscles, these muscles, when the signal is received from the brain, they are able to press the lens, make it more powerful. So whenever lens is more powerful, the muscles are stressed. When it has got less power, then the muscles are relaxed. This is necessary because this we will need in our next chapter, that is microscope. Whenever we say we want to see the image with relaxed eyes means what is relaxed? The muscles are relaxed. There is no tension in the muscle. We are relaxed, but power of the lens will be less. If we want to make it more powerful, then we will have to stress the muscles and we will make the lens more powerful. This will be required in the microscope. We will come to that again. Okay, so this is all the description of eyes. Now we come to working of the eyes. How does eye work? So eye has got to deal with the light, and there are many actions the eyeball and the eyes all together they can do. So working eyeball can be rotated. Okay, if I am seeing an object on this side, my eyeballs will be here, and if the object is on this side, then I will turn my eyeballs on here. If you ask me to see something down, then my eyeballs will be there. If I want to see you, then my eyeballs will be here. So I am rotating my eyeballs. Why? And why should I rotate? Because I want every time that object should be in line with the yellow spot. This line is known as visual axis. Visual axis. This. So, if my visual axis is like this and I am keeping it towards you, if I now all other things are sending the lights to my eyes, the images are formed on the retina, I am able to see all the things. But most clearly I am seeing you. Why? Because I have rolled my eyes in such a way that the visual axis is towards you. If I want to see that fan here, then I will roll it like this. And now this fan is in line with my visual axis, so that the rays going from here are on the yellow spot. Now the rays coming from you are on the yellow spot. So this rolling action of the eyeball, why should we do it? Because we want to make the object on our visual axis. The rays coming from here will form image here. The rays coming from here will form image here. That is why I am able to see the complete room. Because all objects are making images. I am able to serve them. But I am focusing most clearly on something in which line my visual axis is. So this is why we roll the eyes. The second thing, This eyeball can be rotated or rolled, you can say. The second thing is focusing. Focus. Normally we use the word focus. What does it mean? It actually means making a sharp image. Making a sharp image on retina. Now, to make a sharp image on retina, there are certain restrictions. What type of restrictions are those? Here is a lens, and this distance is 2.5 centimeter, approximately, in a healthy person. Now, we have to form a sharp image here. But the problem is, if this lens is making image here, then this distance, what we term this distance as V. We call it distance of the image V, and it has got a focal length F. Now this V we cannot change because our eyeball is 2.5 centimeter. So this V we are not able to change. Okay. Then our object may be anywhere. The object may be at infinity, the object may be closer, and it can be anywhere. Every time we want image to be sharp here. So, how it is possible? Whenever we are changing U, V has to be changed with this formula. 1 upon V minus 1 upon U is equal to 1 upon F. So, 1 upon V is equal to 1 upon F plus 1 upon U. Whenever we change U, the V will change, but we don't want to change V. Then what is the solution? The solution is we will change F. If we change F, then we will keep the V constant 2.5 centimeter. So when U changes, when an object comes closer, the U is decreasing, so the F should also decrease. We will find it, the F should decrease, the power should increase. How? If an object is at infinity, then the rays coming are parallel. The rays coming are parallel from infinity, and they will meet at focus. The focus of this lens is at 2.5 centimeter. Okay, 2.5 centimeter, and it is sharply on the retina. Now if our object is here, now these rays are this way, this. See, I tell you once again, when it is coming from infinity in this direction, this lens has used its power to bend it, and it has to be bent by 10 degree. It will make an image here. So, how much power it has used to bend it by 10 degree. Now, in other case, if this object we have brought here and the rays are going this way, the rays are going in this direction and the image is to be formed here. Now we see again this lens, convex lens, is bending the rays, but this way you now see. This angle is more than this, 15 degree. Here, this is to be bent, only 10 degree. Here, this is to be bent, so it has to be more, 15 degree. That means, if we want to bend it more, the power of the lens should be more. So the lens has to increase its power. How the power is increased? The answer is, power is increased when focal length becomes smaller. How the focal length becomes smaller? When the lens becomes thicker. When the lens becomes thicker, the focal length becomes smaller. So, bending less, bending more. So, this lens itself becomes thicker with the help of ciliary muscles. So that the bending is more, again image is short here. That means, if the object is here, we get the image here. If the object is here, we get the image here. If the object is here, the focal length will change itself, make it more powerful, and again the image is here. If it is here, this will make itself more powerful, and again image is here. Every time image is here, whether the object is here, here. So this is a characteristic of eye, that it makes a sharp image on the retina. Does not matter wherever is the object. So whatever is the distance of object, it accommodates that distance to make a sharp image on the retina. It does not mind whether our object is at 2 meter, at 3 meter, at 20 meter, and it accommodates that on the retina. This power of the eye, this characteristic of the eye is known as accommodation. Accommodation. And this is a very important feature of the eye, that is accommodation. And this is sometimes also asked as an independent question, that what is accommodation of the eye? The answer will be accommodation is characteristic of the eye, due to which whatever is the distance of object, it changes the focal length of its lens in such a way that the image is formed sharply on the retina, and in that way we are able to see the image clearly. This characteristic is known as accommodation. Okay, so this is another thing which the eye can do. And third thing, when the image is formed, then image is converted into electrical signals, and those electrical signals are sent to brain. Converted into electrical signals sent to brain, which decipher into C. For sensation of seeing. So these are the work of eyeball. Eyeball, focus, accommodation is done, and then image is converted into this. The amount of light is controlled by iris. So here we can also write it, amount of light controlled by iris opening. Okay, so these are the 4 things an eye can do. It can first rotate and roll itself so that the object is on the visual axis. Then it will make accommodation or the focus, adjust its focal length in such a way that the image is sharply formed on the retina. Then amount of light is controlled by the iris opening. The pupil will become more, the pupil will become less, and light is controlled. And after that, the image is formed on the retina, and retina converts it into electrical signals. Those electrical signals are sent to the brain, and the brain decipher it. Brain decipher it for sensation, and that sensation we call as seeing. So this is working of the eye. This is working of the eye. Okay, after we have done this working, this is a normal eye which can work. Now if we are bringing the things closer and making them away, what is the difference? The answer is, when we bringing the things closer, the angle made on